right, first type that we're going to go over is adding polynomials. When we add polynomials, we add what is called like terms. Like terms are terms that have the same variables raised to the same degree. So the first thing that I like to do is to underline your like terms. You have a 6x squared plus a 3x squared. We also have a 3x and a negative 2x, and we have negative 4 and positive 12. Okay, therefore I can combine those terms together. So on my Desmos, when we're combining like terms, we only take the coefficients of the numbers. So when I'm adding 6x squared plus 3x squared, on Desmos, I am going to combine 6 plus 3, and I bring down the x squared. So that first term would become 9x squared. I look at my blue underlined terms. That is 3x plus negative 2x. And when I simplify that on Desmos, I'm going to type in 3 plus negative 2, bring down my like term, which is x, and that would become 1x. On the underlined green terms, I have negative 4 plus 12, that is positive 8. Okay, to get my answer, I'm just going to bring those pieces back up. So 6x squared plus 3x squared gave me 9x squared. 3x plus negative 2x was equal to positive 1x. So it would be plus 1x. And negative 4 plus 12 was equal to 8. That is a positive 8, so it would become plus 8. All right, an example of subtraction. The only difference in the problems is the fact that this has a minus sign between the two polynomials. So when you do that on Desmos, you have to make sure that you are subtracting. Okay, I'm going to underline my like terms. I have a 1x squared and a 3x squared. I have negative 4x that can be combined with 2x, and I have 3 that can be combined with negative 4. Okay, 3 with negative 4. So I am just going to combine those terms. I'm going to have 1x squared minus, because this is a subtraction, 3x squared. On Desmos, I'm going to type in 1 minus 3, and I bring down my x squared. So that is negative 2x squared. On the blue underlined terms, I have negative 4x, and it is minus positive 2x. On Desmos, I'm going to type in negative 4 minus 2 and bring down my like term, which is x, and that's negative 6x. On the green underlined terms, I have 3, and it is subtraction, and I'm subtracting the term in the second parentheses, which is negative 4. So I type into Desmos 3 minus negative 4, which is positive 7. To get my answer, I'm going to bring those parts back up. I have negative 2x squared minus 6x, because that was a negative 6x. The 7 is positive, therefore it is plus 7. Now these can be checked on Desmos. You can type in the original problem. You then can type in the answer, and as long as the graphs match, then you know what you have is correct. All right, two types of multiplying polynomials. You can have a monomial times a monomial as in the first one. To simplify this, we are going to rewrite the problem and put the number parts together and the variables together. When I simplify that, the numbers I'm going to multiply together on Desmos. I have 3 times 4 is 12. When we have a monomial times a monomial, an x times an x, we must add the exponents. Therefore, I would add 2 plus 3, and my final answer would be 12x to the 5th power. So when my x's are side by side, I add those exponents together. The second example is multiplication when you have a monomial that is raised to a power outside the parentheses. This is kind of like distributive property. First thing that you want to do is make sure that everything inside has an exponent. Y does, x does, but 5 does not. Because the number 5 does not, it is necessary that I put a 1 representing that exponent. I then multiply all exponents inside by the exponent outside. So that means that I'm going to have 5 to the 1 times 2 power, x to the 2 times 2 power, and y to the 3 times 2 power. Simplify there, I get 5 to the 2nd, x, 2 times 2 is 4, on the y, 3 times 2 is 6, and I simplify to give 5 squared on Desmos, which is 25, x to the 4th, y to the 6th. So this is an example of monomials being multiplied together. All right, on an example, another example of multiplying polynomials, this is distributive property. And distributive property tells me that I'm going to multiply everything inside the parentheses by what is outside the parentheses. Therefore, I'm going to distribute that 3x times everything inside. My distributive step would say 3x times 4x squared plus 3x times 6x plus 3x times negative 4. When I write this out as distributive, I'm using pluses between each of those products. To simplify in the next step, this is x to the 1st power. I'm going to multiply 3 times 4, which is 12. My x's are beside each other. I have x to the 1st and x squared, which means that I'm going to add those exponents. Okay, on the second term, I have 3 times 6 is 18. I have an x to the 1st and x to the 1st that are beside each other. I'm going to add those exponents. And on the last one, I have 3 times negative 4, which is negative 12. And all I do is bring down the x. Then I'm going to simplify. If I add 1 plus 2, that becomes x to the 3rd. I add 1 plus 1, becomes x squared minus 12x. All right, our next example is multiplying a binomial times a binomial, and we have x plus 6 times x plus 4. This is where we are going to use the tic-tac-toe board. We are going to use what is called box method. All right, so I'm going to draw my tic-tac-toe board, and I'm going to put a dot for multiplication in that upper left-hand corner. I put the first binomial on top, so that is an x plus 6, and I'm going to put that plus in the second box to show that it is a positive. Down the side, I have x plus 4. This is just like a multiplication table. You take what's on the left side and you multiply it times everything on top. So for the first box, I'm going to take the x on the left and I'm going to multiply it times the first term on top. So I would have x times x. This is x to the first times x to the first. I know that I have to add those exponents, and that's going to give me x squared. Okay, my second box, I take the first term on the left times the second term on top, and I multiply x times 6, which gives me 6x. Okay, 6x. Then I do the second row. To get the second row, I'm going to take the second term on the left, which is 4, times the first term on top, which is x, and 4 times x is 4x. Then to get the last term, I'm going to take the second term, which was positive 4, times the second term on top, which is positive 6, and 4 times 6 is 24. Now, to get my answer, I'm going to write this out. I have an x squared plus 6x plus 4x plus 24. You are always going to look for like terms, and you are going to have like terms along this diagonal. So you're going to underline the x's, and you're going to bring down your x squared. We're going to add 6x plus 4x to give us 10x plus 24. And again, this can be checked on Desmos. Okay, we can take, and I'll just show on Desmos what we can do. All right, on Desmos, what we can do is type in the original problem, x plus 6 times x plus 4. We have to remember that to type it in, you are always using x, always using the variable x. So if your problem was y plus 2 times y plus 3, you would have to type that in as x plus 2 times x plus 3. At this point, I'm going to do my answer, and my answer was x squared plus 10x plus 24, and you can see that the graphs do match. We know this is correct because the only graph you see is the blue graph, which was the answer. All right, we are going to be looking at dividing polynomials, and the first one we're going to look at is a monomial divided by a monomial. First thing you're going to do is you are going to divide the numbers. So on Desmos, what I would do is I would type into the calculator 6 divided by 2, which is 3. When I look at the problem, I see that I have x's on top and x's on the bottom. This is where I look at the variables and I go through this two-step process. The most important is to ask the question, where is the largest degree of x? If the answer is on top, that means your x is going to go on top. If the largest degree is on the bottom, then that means your variable would go on the bottom. So we are going to look at the x's. The largest degree of x is on top. 4 is bigger than 3. Therefore, my x is going to go on top, and I'm going to subtract those exponents. Okay? Then I look at my y's. I have a y on top and a y on the bottom. Largest degree of y is on the bottom. Okay, 5 is bigger than 2, so that means that I'm going to have y on the bottom, and I subtract my exponents. You always want to make sure that you are subtracting the largest minus the smallest. Those exponents should never be negatives. And then your final answer, you're going to have 3. 4 minus 3 is 1, which is x to the first. And on the bottom, you have 5 minus 2 is 3. Normally, you're not going to see that x to the 1. It's just going to be 3x over y to the third power. You can also check these on Desmos by typing in the original problem and typing in the answer. You cannot use y when you type it into Desmos. All right, another example of dividing monomials with monomials contains negative exponents. And if you have negative exponents, there is a process that you must go through. You must circle all negative exponents. You must then move it. And move it means if it is on top, it goes to the bottom. If it is on the bottom, it goes to the top. And at that point, the exponents are positive. Okay, and then you are going to simplify. All right, so the first thing I'm going to do in this problem when I look at it is I see that I have negative exponents. I have a -2 and a -5. My next step is to move it. That's all we do. Okay, we don't simplify, we don't do anything else. So I am going to leave on top what initially was on top, and that is the 6y to the third power. On the bottom, 4x to the fifth power stays. Okay, now I'm going to move those two terms. X to the -2 power was on top. It moves to the bottom as x to the +2 power. Y to the -5 power was on the bottom. It moves to the top as y to the 5th power. Now we're ready to simplify. I type into Desmos 6 divided by 4. It gives me 1.5. I have to change that to a fraction, so it becomes 3 over 2. My y's are beside each other, therefore I add. My x's are beside each other, therefore I add. So my final answer is going to be 3y to the 8th over 2x to the 7th power. All right, the last example of dividing polynomials is when you have, in this case, a trinomial on top, and it is divided by a monomial on the bottom. Okay, in order to simplify this, we have to rewrite the problem. We must divide each term on top by 2x. So I'm going to rewrite it as 6x cubed divided by 2x plus 4x squared divided by 2x plus 8x divided by 2x. At this point, I'm now ready to simplify. I have 3 dividing monomials. 6 divided by 2 is 3. Largest degree of x is on top, so x will go on top, and I'm going to subtract those exponents. Plus 4 divided by 2 is 2. I have x's top and bottom. Therefore, I'm going to ask where is the largest degree of x, and it is on top, and I subtract. I also have 8 divided by 2 is 4. My x's have the same degree. When my x's have the same degree and I'm dividing, they cancel out. So you will have no x's left. Your final answer is going to be 3x squared plus 2x plus 4. All right. This is a summary of add, subtract, multiply, and divide polynomials. Hopefully this will help.